Hello everyone. Now today we will see the numerical on gear trains. So first numerical we are going to see on reverted epicyclic gear train. The application of this reverted epicyclic gear train, this we are using in the watches, wrist watches commonly. So now in this problem, that is in reverted epicyclic gear train, the arm A, it carries two gears, that is BC and a compound gear DE. The gear B is in meshing with gear E. This B is in meshing with gear E, and the gear C is in meshing with gear D. And the number of teeth on B, C, and D, they are given as 75, 30, and 90. So here you have to find the speed of the wheel C, and also you have to find the wheel and direction of wheel C when the gear B is fixed. Means here the gear B is fixed, and the arm A makes 100 RPM clockwise. Means here the number of teeth on B, C, and D are given, and the RPM of this arm is given as 100 RPM clockwise plus. So here by using the rule, that is PCD is equal to number of teeth. So the summation of the diameter of B plus diameter of E is equal to diameter of this wheel D plus diameter of the wheel C. So from this relation you will be getting the number of teeth on E equal to 45. Means here D and E, they will be having same sense of rotation because they are attached on same shaft, while B and C, both of these shaft, they are co-linear, means they are inline, they are not attached to each other. Now here we will see the table formulation. Next slide. So here the number of elements, these are the four steps that we are following. So how many number of elements are there? You will see here one, this arm A is given. Then the second wheel, that is compound wheel, that is D and E, they are mounted on the same shaft, so we can represent it as a one wheel. Then this gear C is the output from which we are getting the output for this system, and one element is gear B. And in the statement what we are saying, that the gear B is meshing with the gear E. Okay, now so we have to give +1 rotation to which element? To D and E, means the compound wheel D and E. So here arm is fixed, means when your arm is fixed and compound gear wheel DE is revolved through +1 rotation. So here arm A, which is fixed, then +1 rotation is given to DE. Now your this gear B is in meshing with gear E. So if you see in the diagram, so as to find the speed of wheel B, here if your this gear DE is having clockwise sense of rotation, means if D is having plus rotation, then E will be also having plus rotation. And if this E is rotating in clockwise sense, then your wheel B is also rotating in anti-clockwise sense. So in order to find the speed of B, we have relations such as NB by NE is equal to TE by TB. So here TE by TB is minus Y, because your sense of rotation for this wheel is what? It is in anti-clockwise. So it will be minus TE by TB. And now your this gear C. If you see, gear C is in meshing with which wheel? Gear C is in meshing with gear D. So your gear D is having plus rotation, and your gear C will be having anti-clockwise sense of rotation. So the speed ratio will be what? NC by ND will be equal to TD by TC. And the sense of rotation is anti-clockwise, so the ratio will be negative, minus TD by TC. So here you will get minus TD by TC. So this is the first step. Second step is what? You have to fix the arm and you have to give plus X rotation. Here in first step it was +1 rotation. Now here we are giving plus X revolution. So you have to add plus X in every term. Here you have to multiply it by X value. Then third step is what? You have to add Y revolution to all elements. Means here you are, when if for the first two cases your arm was fixed. Now for the third case your arm is having plus Y rotation, and this plus Y rotation is given to all elements. Okay, and last step is what? Taking the summation of step number 2 and step number 3. So it will be Y, here it will be X plus Y, and simultaneously for gear B and gear C. Now since now this is the total motion for every element, means what is the total motion of arm? It will be Y. What is the total motion of gear DE? It will be X plus Y. This will be the total motion of B, and this will be the total motion of gear C. Now since the gear B is fixed, now here we have to find this value of X and Y. Here we have to find the unknowns of X and Y. So here particularly we are knowing that your gear B is fixed. So here, what is the gear B? Gear B, the total motion will be equal to 0. So here equating this equation equal to 0, you will get this term. And your arm is, Y indicates what? The means your arm is having 100 RPM clockwise. So the value of this Y is known. So putting the value of this Y in this equation, you will get directly the value of X. Right? Because what is this is Y, na? Right? So by putting the substituting value of Y in this first equation, you will be getting the value of X. Okay? After getting this value of X, then from the fourth table, you know the value of Y, that is the rotation of arm, and you know the value of X. By knowing this term, directly you can calculate the speed of wheel C. So in this way, the speed analysis has been done for the reverted epicyclic gear train, and this method is nothing but it is called as the tabular method. So then for the next problem, that is for the compound gear train, here this is a compound gear train which is having a sun and planet gear system. Here gear A is the internal gear, that is also called as annular wheel. Then gear D is the internal sun gear, center wheel, and gear B and C will be the compound wheel. Now here, what is the statement here? You have to find the speed of the outer wheel, is inner gear A. So particularly now in this case, if you see here, the annular wheel gear A meshes with gear B and sun gear D. And sun gear D, it meshes with gear C. And here annular wheel is fixed. So you have to find the speed of the output wheel. So how we are going to do? Here we are going to do the stable analysis. Let the number of teeth will be given as TA, TB, TC, and TD, and corresponding speeds will be NA, NB, NC, and ND. So as per the sense of rotation here, we will give +1 rotation to gear D because it is the sun gear, and your annular wheel gear A is fixed. So here gear D will be the first element. Then your B and C is the compound gear, and lastly your gear A. So now here same method, you have to give +1 rotation. So if you see here in the first diagram, if you give +1 rotation to gear D, then this gear D is in meshing with gear C. So the gear C will be having anti-clockwise sense of rotation. And if gear C is having anti-clockwise sense of rotation, the gear B is also attached on the same shaft on which the C gear is attached. So the B will be also having anti-clockwise sense of rotation. And if there is anti-clockwise sense of rotation, your A will be also having anti-clockwise sense of rotation. So in order to find the speed of C, so NC by ND will be equal to minus TD by TC. And for finding the speed ratio of this gear A, that is NA by NB into NB by NA by NB into ND by NC. NC by ND, sorry. So from that you will get this ratio, that is minus TD by TC into TB by TA. Means this will be having negative sense of rotation. Then afterwards, instead of giving +1 rotation, you will do X rotation as per the tabular method. So you have to add all X revolution to each and every element. Then the arm which was fixed for the second step, it will now get Y revolution to all elements. And last step is what? Total motion, that is summation of step number 2 and step number 3. So in this way, we will getting the revolutions or speed or a revolution or sense of rotation of each and every element from this tabular method. Thank you.